It is my amazing privilege, and I will have to read this a little bit because it is amazing and I don't want to mess it up, is that our speaker is an assistant professor in the School of Information at UC Berkeley. Go Bears! Thank you. She studies human-computer interaction with her research spanning education to healthcare to restorative justice, which is an amazing breadth. Her research interests are social computing, human-centered AI, and more broadly, human-computer interactions. Her work has been published and received awards in the premier venues, and our speaker gave me all the acronyms, and I'm gonna spell them out because they're so impressive and it's important. The Association of Computing Machinery Conference in Human Factors and Computing Systems, ACMCHI, Conference of Computer-Supported Cooperative Work, the CSCW, and the empirical methods in natural language processing. So these are amazing theory. I did some reading on this. I encourage you to look these things up. Absolutely amazing. And if that wasn't enough, she's been covered in little things like VentureBeat, Wired, and The Guardian. Those ones that are a little harder to remember. She is a WT Grant Foundation Scholar for her work on promoting equity in student assignments and algorithms, and a member of the advisory board of generative AI, and this tiny little startup named NVIDIA. I'm not sure if anyone's ever heard of them. Even though we recognize that she does go to Cal now, which is a good thing. She teaches for Cal, or has teached lately. She is from this little PhD thing from Stanford. So please join me in welcoming Dr. Assistant Professor Niloufar Salehi.
Thank you, Jerry. That was very kind and very funny. Thank you. Thank you all for spending your afternoon with me. We saw some really cool demos, and that's really what I'm going to talk about. I'll take a step back. As academics, that's what we like to do, and just think a little bit more broadly about what's going on here, what's happened so far, and where are we headed. So what I'm going to talk about is large language models. It's been about 2 years since ChatGPT came out. We've all tried them, and what they mean for work and what they can mean for product management. So like Jerry said, my name is Niloufar Salehi. I go by Nilu. I've been a professor at UC Berkeley since 2018. And I've been doing a lot of work on thinking about human-centered AI and what that means. And so I'm going to come back to this quote, but this is something that has just stuck in my mind since the first time I read it. And it's a quote by Russell Ackoff. The quote is, "Managers are not confronted with problems that are independent from each other, but with the dynamic situations that consist of complex systems of changing problems that interact with each other. I call such situations messes." And this will be very familiar to anyone who's done product. You're always dealing with messes. And we're going to talk about what AI can mean for that mess. There are some estimates that about 80% of data in all organizations is messy, unstructured, and rarely used. And product people are expected to always know what that data is, what the trends are, what we should be doing with that data. And so we'll get into that. But first, this is what we're talking about. I really like this XKCD comic because I think it sets the stage. Whenever I'm talking about AI, I always bring up this comic. So there's this guy who's going like, "This is your machine learning system?" And the other one's like, "Yeah, you pour the data into this big pile of linear algebra, then collect the answers on the other side." And the big question is, what if the answers are wrong? And the person says, "Well, just stir the pile until they start to look right." And that's what we're dealing with at the most basic level. We're dealing with linear algebra that you can keep stirring until it starts to look right. But it becomes profoundly powerful as it starts to get right. And so that's something that we have to be thinking about. And this is something that people across different kinds of organizations and even venture capital is starting to look at as well. So there was this article that came out of Andreessen about the second wave of AI that is less about generating new stuff, but it's about synthesizing what we already have. And that's something that I think is really, really important, and something that we will see more and more of as we move past the initial stage when we were just starting to learn what models can do, and into the stage where they get really deeply embedded in everyday workflows. So I believe that we're at a stage where we're going from the internet era, or where connectivity and information sharing led to really an exponential growth of information and our ability of what to do with information, to a quantum era, where it's not just that we have unlimited amounts of information, but now we finally have the tools to also be able to process and synthesize that information. And that's why I think everything is going to change, but it's also going to change really slowly and in really weird ways, and it's going to take a lot of work to get there. So I'm going to share one project that me and my students have worked on at UC Berkeley, and I'm going to turn this into more of a conversation than me just presenting the work. But we were, about a year ago, starting to look into what would it look like if we used AI more for data synthesis than just for generation. So what if we took these models and we took all this unstructured, messy data, and we tried to use the models to make sense of that data? So I'll pause here and see if anyone's tried to do that. So show of hands if you've tried to upload any of your own data or run a model over any of your own data. All right, so about half the room. And we saw some demos on how to do that today as well. You can go try them out. But I want to hear from the people who have tried it. What has your experience been like? What's gone well and what has not worked?
There's always structure. If you have data set that's not structured in the way that the model is used to, you get garbage out of it, or it just being.
Okay, so the model needs to know what the structure of this information is. Otherwise, it doesn't understand it, and then the output doesn't make sense. Okay, what else?
It's kind of like the cartoon you showed earlier.
Could you say more?
I mean, you expect magic to happen, but it's, somehow like, like messing around with data, like you get something different, like maybe more structure, etc. But instead of the synthesis, you're spending, or at least like more time spending on like data, like editing more. So to go out and
So you're expecting magic, but it's not really working out, so you have to iterate a lot. How do you know it's not working? So the output doesn't make sense. What else? What have other people's experiences been?
Setting up a testing framework to answer that question turns out to be the hardest question to answer, because you're literally asking fundamental product questions in trying to evaluate the effectiveness of the system and promise.
So evaluation is really hard, yeah.
And yet, answers that you get from the prompts are different. And sometimes you get answers and then that's something you were expecting. Then you use the same prompt for different thing, but it doesn't work. Like let's say if I upload a data and I ask some questions, sometimes it gives me the right answer. If I ask the same question to a different set of data, which has a little bit different dates, then it will give a different answer. And it goes in a different direction altogether and you get lost.
Right. That's a really good point. So because these models are non-deterministic or stochastic, they don't necessarily do the same thing again. And I think that that's a really big key to how this will all play out. I think we're moving past the era of software where the software was always deterministic. You knew exactly what you would get out. If you ran it 100 times, you would get the same thing. Into an era where a lot of things are going to be really noisy. And evaluation is going to be really hard. So a colleague of mine, Joe Gonzalez, and another colleague of mine, Joe Hellerstein, started a company. It's called Run LLM. And they did all these blog posts about a year ago where they were saying, everyone's evaluating their LLMs off of vibes. And this can't work. So, you know, we have to have some kind of benchmarking here. And a lot of people have tried to do LLM evaluations and benchmarking. And just a week ago, I saw a blog post come out of their company. And the title of the blog post was, "In Defense of Vibe-Based Evaluations." After a year of trying to create benchmarking, they had realized that even if they really put a lot of effort into a good benchmark, it still didn't mean that their end users felt that this was a better LLM. And what the end users were doing were going in, asking a few questions, and seeing how it looks like and how it feels, and just the vibes. And the blog post was saying if that's how the users are evaluating it, then maybe that's not so bad. Maybe we should be thinking more about that. So I think there are some fundamental things that are going to change. Yes?
Another big problem is often like 95% of, you may get situations where 95% is accurate and 5% is not. And it's easy to, one, if you don't really understand the domain, to just think it's 100% accurate because you're seeing a bunch of things that look accurate. And detecting which parts are not, hallucinations is another problem. And so I think that the veracity of what you receive and can you fully trust it. And in some domains, you can't afford to have like 85% confidence or even 90% confidence. You need like 98, 99, 100. So I think that's another big problem.
That's exactly true. So even if I know that I'm 99% of the time correct, I don't know what those 1% are. And that's another really big problem. Because our brains are just not used to tools that work that way. If I drive a car around LA and it's working pretty well, I expect that if I come to San Francisco, it'll work just as well. And that's how our brains function and how we think about tools. And now we're entering into an era where I really don't know why these models keep using the word "in the realm of something." Whenever I see an email and it has "in the realm," I know that it's AI generated because no person uses that word. But I don't know why the models keep using it. So it's going to be weird, and we're not going to be able to understand why. We have a lot of experiences in this. About 4 years ago, I started working on models used in really high-stakes settings because I was thinking, if these models keep going to get better and more embedded, we have to know how to make them reliable. And so I thought to myself, let's take it to the extreme. What is a setting in which you absolutely cannot be wrong? And I thought, well, hospital settings, because if it's life or death, then you absolutely cannot be wrong no matter how good the model is. And so we started looking at language models, early language models, translation models used in hospital settings. And one thing we learned was that Google Translate was widely used in hospitals across California. And so we started this study. Let's actually try this out with this group. So say you have a doctor, say you're a doctor, and your patient comes in, and you want to tell your patient, hold your kidney medicine until you've had a chance to speak to your kidney doctor. So you just got their lab results back and you have to give them this piece of information. Now your patient comes in and they don't speak English, they only speak Mandarin. Now you have a choice here, which is to put that information into Google Translate and hand it to them. Or you could, go try to find a way to find a Chinese interpreter. Now let's do a show of hands. If you were that doctor, would you give the Google Translate output to your patient? Let's show of hands if that's a yes. Okay, I think about 30%. And what if it's a no? Okay, 70%. So this is really interesting for me because I usually talk about these things to a technical audience. And when I speak to a technical audience, almost no one raises their hand for a yes. Everyone's an absolutely no. But when I go and talk to doctors, because a lot of my collaborators are doctors, all of them do this routinely. And so I always use this as an example to say that the doctors are being super practical, and the technologists are thinking about it in this 0 to 1 numbers way. And it's interesting to see that product people sit somewhere in the middle, where we understand the tech, and yet we know the reasons why we need to be practical as well. Yes? Go.
Have you had a doctor put something like that into Google Translate and had somebody who speaks Chinese translate that into English for you?
So my colleague, Dr. Elaine Kung, who's at UCSF, has a lot of Chinese patients, and she does this all the time. She puts all her notes into Google Translate. And so a lot of the times the patient comes in with someone with them who may know some English, and so yes, they do that. But we did run this experiment where we actually tried using Google Translate to back translate. So I'll talk a little bit more about this a little bit later, but yes, sometimes people do things like that. Yeah.
Are they not worried about in case they get it wrong and they change like a medication or something and they end up taking the medicine they're supposed to or vice versa? You could get.
Yes, liability is a big issue.
Yeah, absolutely.
Question number one is how accurate have you found it to be? Seriously.
I will. You're good.
I was going to ask, I think back translating might be what I was talking about. I personally would have directly translated, but I would translate it, I'm not sure if the patient, but I translated it back into English to see what it retranslated as, and then if it seemed reasonable enough, perhaps I would show the original correct translation. Is that what factors that you mean?
Yes.
So there's even a button in the middle of Google Translate for flipping it around. So
Doctors do that as opposed to directly.
some do, not all. We actually found a hospital somewhere in California where the guidance to doctors was to do that, to back translate. But you're completely right. There's absolutely no written rule anywhere, and the liability lies completely with the physician who did that.
One thing you could do is use a different translator to try.
That's a really good point. That likely will work better.
Does that also be, because you're talking about human-centered AI, there's an angle which we talk about is the doctors rely on their nurses and on their staff to actually provide the actual support for patients. So even if they use Google Translate, it's dependent on the nurses to make the final translation for those patients. So it's slightly lower in an actual hospital or clinic setting, where nurses are much more involved in direct communication with patients.
Well, I guess in this scenario, the liability would be with the person who gave the incorrect information. So the example that I gave you was a sort of a trick question. It's one where Google Translate, at least up till 2021, was flipping the meaning. So hold your kidney medicine until you've spoken to your doctor was an actual sentence that someone was given in hospital discharge instructions that my colleague found. She had a big database of things that she had said to patients. So we ran it through Google Translate, translated it, had someone who understands that language look and rate, and there were about 8% of the sentences that were not only incorrect, but were incorrect such that they caused clinically significant harm. And the sentence that I said was one of those. It got translated to keep your kidney medicine. And so this is an example of these sort of errors that are very hard for us to identify because we don't know when the model is going to be right and when it's going to be wrong. And even if we know a percentage of 8% of the time it's wrong, that still doesn't help me on an individual basis when I'm working with these models. And so I think the next generation of tools that we use are going to be completely different, and everything about them is going to be different. And I think that means a lot for product managers. We're going to have tools that are stochastic, that are not always right, that you can't even really run an evaluation with because each time you run it, something different is going to happen. I think that that's going to touch every aspect of the product. I think it's even going to touch pricing. Because so far, we're so used to a per license or per seat pricing model because it was kind of the cost of running software was pretty much the same for each person who joined, right? But now we're at a point where it kind of depends on how much they use it. The models are actually the thing that's really expensive. And so we're seeing some startups do token-based pricing, or there's even one startup that's doing this really innovative thing where they're doing outcome-based pricing. So they're saying, we'll help you answer your support tickets, and we will take a percentage of how many support tickets we close. And so I think we're going to see more of that because we're going to see more and more tools that are more involved in the actual doing of the work than just being a tool that you use to do the work. I think we're going to see more and more, I think we're going to see less of those things that have become so standard where, those tables that every company has, where it's like our features and what the competitors' features are, and there are ticks in them, like we give you 20 gigabytes of storage, the other company gives you 10. I think that those are all a product of software that was very deterministic and very easy to measure. And we're going to see less and less of that. I think, ChatGPT and Gemini have been around for a while. There isn't a single table that compares them like that. And most people just go off of vibes, or they try it a few times. And I've heard some people who really like Gemini and some people who really like ChatGPT. And I'm sure some people love Storytel. And so I think that we're going to see a whole new way of how people, evaluate software, make decisions on what software to buy and how to use it. And there are going to be really, really important questions around reliability here. Because these are non-deterministic or stochastic systems, I think that reliability is going to be the most important thing. And the way that I think about reliability is two things: accuracy and verifiability. And so going back to this project that we started about a year ago, this is me and my students, we started to think about, okay, what is it going to look like if we use models for what we believe models do really well, which is go through lots and lots of data and find out the patterns, insights, or even take actions on behalf of the person. And so I teach HCI at Cal, so a lot of my students end up going into product roles or UX research roles. And so we said, let's try it out on something that we do all the time, which is go through user data and try to understand what people's pain points are or what we should be building next or those kinds of things. Now, I think conversational interfaces are great. I think they come very naturally to people, but I don't think the future will be a lot of one-shot interactions with models. I think that models are good at certain things, but for a lot of the workflows that we see people actually do, it's actually going to take longer forms of engagement with multiple different models or different kinds of algorithms. And so we said, okay, let's build 3 template workflows, and we call them widgets. And what each widget does is it takes some unstructured data and solves a problem for a potential product manager. So the first one is a Q&A widget. That one is just, you have your data, you can ask questions about it. The second was pain point tracker. So we said, let's say you have all of your data, say reviews from customers, and you want to know what are the main pain points that customers have and how have those pain points changed over time. So we made a widget that you can drag and drop over data, and it draws a graph for you of here's your pain points that your customers mentioned, and here's how they've changed. And the third one, we call this one User Insights widget. This one takes a lot of qualitative data, and you can either ask it specific things that you want out of that qualitative data, or you can just say, just find out the main trends here, and it goes and it searches through all that data and it pulls it out. And it gives you a whiteboard with each trend being one of those squares, and it puts sticky notes in it. So we thought of these 3 workflows as things that we think would be really helpful for product managers. And so I'm going to show you a video of the thing that we built. Now, mind you, this was a research project mostly coded by students, so it's not... can we start playing it? OK. I think we need to get rid of that thing. Awesome. Thank you. So this is what we ended up building. So there's a space here, and you can pull in data. We ran this study with Notion reviews. So we scraped App Store reviews from Notion that had 3 stars and below to test the pain point tracker widget. So I think if each one of these data points is a review that someone wrote on the App Store for Notion. And the task here was, it's impossible for someone to read all of these, but what if there was a widget, and the way you run it on this data is whatever data is in the middle is what these widgets will be run on. You kind of give it a name, and you can either give it specific pain points you want it to go look for, or you say, find the top 3. So when you run a widget over data, it starts to run, meaning that it's going through all the data, analyzing with an algorithm, and the output is the spreadsheet with, here are the top 5 pain points that everyone mentioned, and here are how those pain points have changed over time. So this is how many times each pain point was mentioned each month. And there's a graph here. You can see laggy and glitchy on iPad was mentioned 5 times in August, and then it went down, so it probably got resolved. But another pain point, lack of intuitive design, is going up in Notion App Store reviews. This is the Q&A widget that I talked about, where you can ask questions from the data, like what are the biggest challenges with Notion AI? It goes through that data, puts together a response for you, and it tells you its sources. So that's where the verifiability comes in. And you can keep running these widgets. We've tried to make it really flexible because our goal was to see what will people do with these kinds of things. This is another example of the widget. This is more for qualitative interviews. So we actually got these off of YouTube. So there are reviews that someone did off of the Notion app. These are YouTube video transcripts. So we took the transcript, and these were also very long. So we took tasks where like actually doing it manually would take hours and hours and hours. And we built widgets. So I think I'll do the user insights one. So you give it a name, you can give it specific topic areas that you want it to go look for in the data. Like, I want to know more about the calendar app, and I want to know what people are saying about the AI output, because Notion added an AI bot. And so it goes, analyzes the data, and puts it all together. And the output looks like this. So it makes a whiteboard where there's a box for each user, a little summary of that interview, and then all the questions that you had. It makes little sticky notes for each of those things, or anything that it finds in that data. So this is for user 2, what they said. And then there's a summary table at the end for each of the things that I was interested in and each of the users. What did I hear? All right, so this is what we built. And our goal was to see, how do people use this? Is it useful? What can we learn from giving this to some product managers and having them use it for something that resembled a real-world task? So if we could go back.
Yeah, of course.
And then what tool is it built on?
We just built it from scratch. It's just a web app.
Okay. And how like the data that you're putting on,
Yeah.
and they were running for this visualization.
Yeah.
So how like from there is a qualitative, or like taken from the different data from the internet comments or motion comments.
Yeah.
People have from there put up and then.
Yeah, so my students built this web app. They had two ways to bring data in. One was that you could just upload data. The other one was they wrote a script that you could sort of get reviews from the API with the Apple Store. They did that. It can scrape that, or it can take YouTube videos or things like that. Yeah. Any other questions about the tool? I'm going to share what we learned from running some studies with it.
How long did it take for these students to go?
About 6 months.
So if you guys, what API would those other folks use on single one or use full stack?
So we tried a lot of different things, and they're not all LLMs. So our insight was that it would be more interesting if, for each workflow, we designed an algorithm for that workflow. So for instance, for the pain point tracker, there are multiple things that need to happen. The first is that you have all this data. You need to pull out what the main pain points are. Then you somehow need to cluster them, because we need some understanding of what the groupings are. Then for each cluster, you need to count how many times they come up. And so we designed an algorithm that does that, and we tried a few different things. So the first thing we tried was, for each review, let's pull out the pain points. So one sentence for each pain point. Now we have a long list of sentences. Now let's use a clustering algorithm to cluster it. And then for each cluster, let's figure out what that pain point, what that cluster represents. And what ended up happening was that there was so much information lost because we did the summarization too early that it didn't really work. And so we tried something else. We just chunkified the text, so each chunk was about a paragraph. We made a vector for each of those paragraphs, and then we clustered the vectors. And now we had a bunch of clusters. Some of them represented pain points, some didn't. And the way we figured out which ones are pain points is that for each cluster, we would sample 2 or 3 of those clusters, and we would give it to an LLM, I think we used ChatGPT, and say, hey, do these couple sentences represent a pain point? And if they did, then we would sample a few more and figure out what that pain point was. And if it didn't, we would just throw away that cluster. And that worked better. And so that's part of my point here, is that I think it's going to take a whole lot of work to figure out how to develop these workflows. It's going to take lots of algorithms. It's going to take different kinds of models that are good at different things. And we're going to move away from one-shot interactions with a single model, I think, towards figuring out what needs to be done and just designing an algorithm that does that really well. Does that answer your question?
Yeah, I guess, yeah.
Cool. So for the user insights, we did a similar algorithm that would go through. There were 2 paths, right? One was if the user asked specific questions. The other one was if the user just said, find the top trends. And so we developed an algorithm for each of those. The Q&A was the easiest. That was just basic RAG. Yeah. Any other questions? Yes.
Have they used RAG scraping and helping the network level for that data or motion API?
Yes. Yeah, so the reviews were with the API from the App Store. Those were scraped that way. The YouTube videos, I think they just did it manually. They just took the transcripts and uploaded them. So we did a user study on this. We had 16 product managers spend about 2 hours doing a pretty realistic task with this. So we said, imagine that you're the product manager at Notion and you have all this data. And we want you to end up with basically a document or next steps for Notion. What should they focus on next? And we gave them access to all 3 widgets. We did a quick overview of them of how to use the widgets, and the data was already there. And we started to look at how they use it. What we found was that they used it to navigate large amounts of unstructured data. So most people used all 3 widgets. And we thought that was really interesting because with the amount of time that they had, about an hour, there was absolutely no way that they could actually go read all that information. But they made use of the widgets to navigate that large amount of information, find the patterns and what's important, and they used that to write up a document of next steps. We found that they had really different workflows, and I thought that was really interesting. And I think a big takeaway here is that this next generation of tools is going to require a lot of customization, because this is a few of the workflows that people did. So the blue ones here are anytime someone used the user insights widget. The red ones are when they use the pain points widget. Q&A is orange. And gray is when they try to do it manually, or they just opened a few and just read it to get a feel for it. And so each one of these columns is one person's flow. So this first one, this was someone who read the interviews, then picked a few of them, then brainstormed, and then just did the Q&A once to ask, what are the metrics? The second one started with user insights to get an overview of the data. Then they went to pain points and got an overview of that data. So they did a qualitative followed by a quantitative analysis. Then they went back to user insights and they ended with 2 questions. And then there were some people who did really weird things, and they did loops and they went back and forth. But each person had a completely different flow. And I thought that was really interesting because I think it teaches us something about what people do well and what models do well. I think the PMs relied a lot on their intuition and what they know contextually about the company, the business, the technology, and what needed to be done. And they used these as tools in different kinds of configurations. Another thing we found was that they did a lot of cross-verification. So anytime you see one of these sort of arrows that goes back and forth, they would do one widget and then do the same thing on the same data, or ask the question slightly differently and try to understand if it was right or not. And so I think we're starting to pick up on the behavioral patterns that we need to have to be able to work with these stochastic models. Is a lot of verification, a lot of trying things multiple different ways to see what happens. And so we found that there were 2 main ways of thinking that people used Yodeai for. And I forgot to say, I think the tool was called Yodeai. So they did divergent thinking, where they were branching out, generating multiple different kinds of solutions. And they did convergent thinking, where they were trying to converge everything together and prioritize. And we thought that they would probably use the widgets only for convergent thinking. Our initial hypothesis was that people are good at divergence and creativity, and models are good at, synthesis and pattern matching and bringing everything together. But what we found in practice was that they used the widgets for both of those things. And so it was a lot more mixed and iterative than we expected. We found that they did use it a lot for brainstorming. They used it to come up with new ideas, come up with assumptions that they might have missed, and to discover new insights. And we found that they did do a lot of trust building through transparency. So one of the things that we did right off the bat was that anything that was generated with its source. So they could always validate, and they really appreciated that. But they also did other sorts of creative forms of validation, where they would ask one widget to do something, and then the other widget to do the same thing, and cross-validate that way. There were some challenges that we didn't expect, though, and I think those are really interesting. So one thing, our initial hypothesis was that the person has to be in charge, and they have to decide what widgets to use when, and they have to configure the widgets. So for each widget, there were some things that you could configure, like what questions do I want to ask from this data, or what data to even run this on, and when to use the widget. And we thought that this would be great because we wanted the person to be in the driver's seat. But in the follow-up interviews, people did talk about confirmation bias. Because they were like, if I have this hypothesis that something is going on in this data, if I ask that question, the model will go find the evidence for the thing that I'm trying to find, right? Because there's so much data, it has to be somewhere in that data. And so they actually wanted sometimes for the sort of widgets to push back, or for there to be someone to question assumptions and stop them from over-relying. They also worried about over-reliance on these AI-generated insights if someone else on the team was coming up and saying, hey, this is what the Yodeai widget said, and now there's no conversation, we have to go by whatever the AI said. And they were worried about that might lose some of the depth of understanding that you would get from actually spending hours and reading this stuff and really getting deep into it. They also worried about decision-making in high-stakes settings, requiring human oversight. And one thing that I think is really interesting was that they were talking about how I, as the PM, know things about the business that the AI cannot know because it's not even in the data. Most of what we know contextually and through conversations is actually never recorded anywhere. So there's no way for it to be in any data that could end up in a model. And so there are these things, sometimes we call them human intuition, sometimes it's just the art of, say, product that models just don't have access to, and so that's really important if there's over-reliance on these models for decision making. And so there were 3 key takeaways for what people actually wanted. User control was, of course, one, but they also talked a lot about accountability and ethical consideration. One thing that they loved was that with the widgets, they could look at the same data at different levels of granularity. So the fact that they could pick which widget to use and how to run it and go really deep into the data with question answering, or get this high-level overview with just the pain point tracker, that is something that they really liked, and I think is a good design pattern as well for other people building tools, or if you're incorporating these kinds of models in your tools. People really like having that granularity of options. They talked a lot about the creativity versus objectivity. I think we're starting to see this a little bit where tools like Grammarly and some of the other generation tools now give you the option of picking your tone, or some of them allow you the option of picking the temperature. Now, temperature is something really technical in the model. Sometimes it means higher temperature is higher creativity, but what it really means is that high temperature is higher randomness, and sometimes that leads to creativity. So I think we'll see more and more of these sort of granular options and adaptations made available to end users. And they really cared about it being customizable. And I think that's really important because each person did something completely different. And so I think that's a big design lesson as we're building more of these tools. They cared a lot about accountability. I think that's really important. They wanted to know where the outputs come from. Has anyone had experiences with this where you have an AI output and you kind of want to know, okay, but how did it come up with this output or this idea? Have you seen examples of it working well?
Perplexity is.
Can you say more?
I mean, that was one of the reasons, I thought Perplexity was different, because it gives you 4 or 5 sources.
It gives you citations.
And then I think that the main, key from that is to use another model. You don't know what the source is. But if you look at the sources, in certain cases, you're like, okay, now I get why, it's kind of this how. Look at the sources and say it's all the beef industry is talking about why beef is good, so.
Right, yeah. So citations has been very successful, yeah.
Right, so the citations or the reasoning kind of develops the trust in the user. For example, like when Gmail tells you this is spam, I don't want to believe that blatantly. I want to understand why did you mark it as spam? Maybe because I deleted the last 5 messages, emails that look like it, and that will give me clarity, okay, you're doing a good job because you're explaining what you're doing and why you're doing it.
Right, yes.
So there's been a lot of research into explainability. So when a model produces an output, can we explain how it came up with that output? And sometimes we can. If it's certain kinds of models, we can. But for a lot of the models, and especially the newer ones, the black box ones, there's actually no one knows anything about how it came up with that idea. Now, there are some approaches of post hoc explanations, which is, I know that this really great model, this really powerful, did this thing. But now another model is going to come up with an explanation for how it got there. Now, the problem is that the other model might be wrong. And so there's been a lot of debate about whether that's even useful or not.
Right. Any? Yeah.
So how did this model came up with the questions, whether it's a user bias or like what kind of questions you're asked to the user to extract the right information? So how does it work? And also the algorithm that has been used here. But is there any current tool available in the market that can fully extract in that way to API and get the data?
I think there are. Yes. Oh, yeah, of course. Thank you for reminding me. So the question is, are there any tools on the market that can do that kind of a thing of, scraping am I correct? Scraping the data and then doing that kind of analysis. I think there are a few on the market. I think Syncly is one. There are a few startups that are doing this kind of a thing. This was, of course, a research project, so it's actually on GitHub if you want to go run it yourself. But I think explainability was something that everyone wanted, but I'm not sure how much we can actually get there. We did the citations thing. I think that that's always useful, and that's fairly easy to do. As long as you know where the data came in, you can just cite it. Yeah.
With some of the LLMs, like I recently did this with ChatGPT, I asked it to explain how it got to its answer. But then it comes back to the veracity, like even within the same model, how trusting can it be at the reasoning game, especially because with temperature and other things, and it doesn't have, unless there's history that it's really saved the execution plan, for lack of a better word, that it went through.
Yeah.
How accurate is it going to be able to be to explain what?
Zero accurate. Because so ChatGPT is using transformer models, right? It's billions and billions of parameters, and no one knows how it went. And so asking it post hoc to explain what just happened, it just doesn't have access to that data. So it will come up with something, and that's the big problem, right? It always comes up with something that kind of sounds reasonable, and our brains, we just can't deal with that because we're it kind of is mimicking another person. And we're socialized and sort of hardwired that when another person tells us something that kind of sounds reasonable, we just accept it. And that's how we've been able to live as social beings for millions of years. And so I think that that's a really big design question, is how do we as product managers and designers create these interactions that explain to the person what is actually going on in a way that they can use it reliably, but that it doesn't become misleading. Yeah.
I think a lot of what this fits in the projects that I've had is just being able to debug these issues when they come up. Had issues where I monitored like a custom assistant over the AI and saw a response and I just had no idea how it could have possibly responded or produced that.
try to run the same exact string of prompts that you can reproduce it. Whereas typically in code, we reproduce a scenario, we can trace the outcome and then fix the issue. Yeah, a lot of times in product, that one bad interaction is the bad review in the App Store can hurt you.
Exactly.
That's the sort of vibe-based evaluation, right? I always ask people, what is your favorite LLM chatbot? And it's always a mix. Some people love Gemini, and some people love ChatGPT or Perplexity, and I always ask them why. And it's always this one time I asked it to do this thing, and I did it wrong, and I asked the other one and did it right, and then I completely switched. And that's going to be a big problem for product managers, right? Because you're the one who have to then explain to management why you lost this customer because of vibes, and then you have to go tell the ML engineer to fix the vibes. But I think transparency is something that people care a lot about. It builds trust. And so maybe even you don't give the best model to the person right off the bat. Maybe you build trust with them first with a model that maybe is worse but makes less mistakes. There have been some people who have advocated for not using black box models at all in really high-stakes settings like medicine. So we can have a deep learning model, which we know nothing about how it works, and it can assign medicines with, say, 80% accuracy. Or we can have a deterministic just algorithm that maybe is a little less accurate, but we always know why it did the thing. So a doctor can go look and say, one of my friends, Hima Lakkaraju, who's a professor at Harvard, did this study where they built a system, a model, that takes the inputs and outputs of a big black box model and builds a deterministic algorithm that more or less does the same as what the big model does. So these types of algorithms are very common in medicine, where if you go to the emergency room and you present with certain symptoms, usually it's an algorithm. They're like the age of that person, and then it branches off in a flow chart, what are their symptoms, and then they end up with what they should do with you. And so she built a system that builds a flow chart like that off of how a big model that was trained on a lot of data acts. And it was really cool because then you can go look into it and see, oh, it's discriminating against women on heart attacks. Because then you can see how it's coming up with that thing, right? But the thing that it came up with isn't exactly what the big model is doing. It's just an approximation. We think it's doing it that way. But there are people that say in high-stakes settings, we shouldn't be using the big black box models at all, and we should stick to things that are deterministic. Now, for products, it's a little bit of a different story because sometimes the big black box models are so good that they can lead to, a ChatGPT moment. But then you have to think about what is the worst thing that could happen to a user with this model? And how do I build trust with them when they've just joined? And I think those are all things that we're going to see more and more of. Audit trails were something that people asked for, especially in collaborative settings. That's exactly the sort of, I did the same thing twice and I got two different things. And that becomes a problem if it was your colleague who did it and got one thing and you did it and you got a different thing. And so I think we'll see more and more of sort of accountability measures on top of models. Logging inputs and outputs is something that a lot of companies are doing. And I think we might see more and more of that being made more transparent to end users. And the last one was people wanted explainability of what the limitations of the tools are. Just like more, end user education on what it can and cannot do. And I'll end with some ethical considerations that our participants talked about. Privacy and confidentiality was, of course, a big one. Any kind of enterprise tool is going to deal with that. I think companies have gotten much more privacy aware, and especially with some of the things in the news about OpenAI or other companies, training on people's data, I think they've just become a lot more conscious of that, and that's important. Ways to mitigate the confirmation bias of what the model tells people came up. And they talked a lot about balancing the sort of benefits that they saw coming from automation with the human insights. So they talked about things like, this automation really increases my efficiency, but there needs to be a balance with me and my intuition and my central role as the decision maker. So AI tools is enhancing, but not replacing human judgment. So I'll end there with three key insights. I think one thing we learned was that the LLMs are super flexible but very unpredictable. So there's a big challenge ahead of us on how do we build products around these models that make use of how powerful the models are, but lead to users actually trusting them and using them reliably. And then we did some comparisons to more deterministic ways to keep data, and one of those is knowledge graphs. So you might have heard a lot of companies are now incorporating different kinds of knowledge bases in addition to LLMs. I think that we'll see a lot more of that kind of a duality where LLMs or models are very good at language generation, very bad at being reliable. And the other end of the extreme is reliable and deterministic knowledge sources like knowledge graphs. And so I think we'll see more and more combinations of these kinds of things and user-guided combinations of these kinds of things. So I'll stop there. Thank you so much for listening. And